The following is an example of finding an inverse function using inverse function notation. Find the equation of the inverse function of x of f of x equals x cubed plus 4. Firstly, we'll change f of x to y. So I'm going to rewrite this function as y equals x cubed plus 4. Next, swap the x and y variables around. So where you see y, replace it with x, and where you see x, replace it with y. Next, we make y the subject of the formula. So y cubed equals x minus 4. Taking the cube root of both sides, we have y equals the cube root of x minus 4. And finally, we express the inverse function using the inverse function notation. So f to the power of negative 1 of x equals the cube root of x minus 4. Now I'm going to verify if the inverse of f of x equals x, or the inverse function of f of x equals x, and the function of the inverse function of x equals x. So in other words, do we get back to where we started? So starting with x, do we end up with x, the identity? So the inverse function of f of x is the cube root of f of x minus 4. So I'm just replacing the x with f of x, and f of x is x cubed plus 4. So substituting that for f of x, we get this. Okay, so the cube root of x cubed plus 4 minus 4, expanding the brackets, and the plus 4 and the minus 4 cancel. We have cube root of x cubed, and that gives us x. So that certainly works there. What about the function of the inverse function of x? So sort of doing this in reverse. So that's the inverse function of x all cubed plus 4. So that's the cube root of x minus 4 all cubed plus 4. Now the cube and the cube root cancel, so we end up with x minus 4 plus 4. Of course, minus 4 plus 4, they cancel as well, that gives you 0. And we get back to x.